This is the configuration utility used to create the SoftHub configuration file. A SoftHub configuration file consists of two main sections. The Systems Options section, which is where you can set global systems options, set up email and SMS send capabilities, and enable any input or output GPIO pins you wish to use, and a Rule Engine section, where you create the rule set that will direct the SoftHub to perform your application. This is the configuration file that was used to run the demo. In the Rule Engine section, we've created several objects and a handful of rules that reference those objects. At the heart of the rule set are the rules themselves, which are created under the events that trigger their evaluation. As events are fed into the Rule Engine, it will sequentially evaluate each rule you associate with that particular event in the order you specify. The demonstration example required 9 rules which were triggered by 6 events. Each rule has 3 components: the triggering event, a list of 1 or more actions to be executed, and optional conditional logic which can be used to bypass processing. In this first rule, the triggering event is the SoftHub application starting. There is no conditional logic, so all of its actions will always be executed, which in this case consists of only a single action object, which initiates the connection to the NXP Rapid IoT multi-sensor. Once the sensor connects, a Sensor Connect event will be queued to be processed by the Rule Engine. For the Sensor Connect event, we only have a single rule to process, and again have no conditional logic, so each of its action objects will always be executed. The first action object will create and initialize a counter object we'll use to keep track of the number of tap events detected. The second will create and initialize a flag we'll use to keep track of when we are in tap mode, which basically is any time we are not in the process of sending a temperature reading. The third object writes to the NXP sensor to enable notifications from the tap count characteristic, and the last object writes to the value of the sensor's LED characteristic to turn the LED green. Next, we'll look at the rules that get evaluated whenever we receive a new packet from the sensor. Again, it's important to note that while events are processed in whatever order they arrive, the rules associated with an event are always evaluated strictly in the sequential order specified. When a new packet arrives, the first rule to be evaluated has some conditional logic defined. Before any actions are carried out, the conditional logic is evaluated, and if the conditional logic evaluates to true, all of the rule's actions are executed, whereas if the logic evaluates to false, none of the actions will be executed. Our simple logic in this case checks to see if the tap mode flag is false. If it is false, the packet being received would be from a temperature read request, so our single action object will forward the packet to a remote server. Conversely, if we were in tap mode, this rule's action would not be executed, as the packet would be a tap count notification, which is not data we want to forward to our remote server. The next rule's conditional checks that we are in tap mode. If so, then the packet will be a tap count notification, so this rule will simply increment the counter we created to keep track of the number of taps received. With the tap count incremented, the next rule is evaluated to see if we are in tap mode but are not on our third tap. If that logic is true, we'll stop and restart our 1-second tap timeout timer. Lastly, if we are in tap mode and it is our third tap, we'll do all the actions required to switch modes. First, we'll stop our tap timeout timer. Then we'll write to the sensor to disable tap count notifications. Next, we'll write the sensor's LED characteristic to turn it to red from green. We'll set our tap mode flag to false. We'll initiate a read for the temperature characteristic from our sensor. And lastly, we'll start a 5-second timer we'll use to switch modes back again to the tap mode. When that timer expires, it will generate an expired timer event. When that event arrives at the SoftHub's Rule Engine, a single unconditional rule will be evaluated, which will set the tap mode flag back to true, reset the tap mode counter to 0, turn the LED back to green, and re-enable tap count characteristic notifications from the sensor. The one other timer-related event results from the 1-second timer we set when we detect a new tap. If the user taps the device before the timer expires, the timer gets stopped and restarted so this event won't get queued. If, however, a full second elapses between taps, the timer will expire and its single action object, which resets the tap count to 0, will be executed. Our last event is the event indicating the SoftHub application is shutting down. The system will take care of disconnecting the sensor by default, but will turn the LED off before exiting to indicate to the user that the application is no longer active. We've obviously glossed over a lot of detail here, but before we go, we'll look at how objects are created and also at an example action object that was used for the demonstration. New objects are created by right-clicking on the object type and selecting New. For sensor objects, you'll need to select the sensor type, and then you'll be presented with a list of sensors of that type. You can use the drop-down to select the specific sensor you want to connect to. Once you do, you'll see a full list of all characteristics for that sensor that support reads, writes, or notifications. As we'll see shortly, there are dedicated action objects to control those operations. Looking at the sensor object definition we used in the demo, you can see we enabled 3 characteristics: the temperature characteristic, the tap count characteristic, and the RGB LED color characteristic. This is also where we originally specified the associated sensor connect and new packet events we used to trigger some of our rules. Lastly, let's have a look at one of the action objects that was used. The object type is an initiate BLE write action object. When executed, it will write the user-specified hex string to the selected sensor and sensor characteristic the user has chosen from the drop-down list of previously enabled sensor objects. The SoftHub supports more than 60 action object types, which are all fully documented in the SoftHub configuration guide available for download at the Omniot website. Also note that there is a link in the Hackster project file to download the configuration file used in this demo. To use it, you would only need to change the IP import specified in the SendData action object to point to your own packet capture server. Thanks for watching.